Here's the fourth video in the series of videos on solids. In this video, we look at cross-section. A cross-section is a cut which is made through the solid, and it is perpendicular to the length. So this is perpendicular, right? And here also you see it's perpendicular to the length. What it means is, you can't make a cut like that. That's not perpendicular, right? So, and even you can see that in a cone also you can have a cross section, but here the perpendicular means it's perpendicular to the axis. Okay, so it's a cut which is made in a solid which is perpendicular to the length or height. There are you can see that for this cuboid, in this cross section and in this cross section, you will find that the cross sectional view, when you look at it from here, is going to be the same, right? So you will see that this will be for B, and for A you will see again it's exactly the same square of or rectangle of same as A and B. Yeah, so for A and B they are equal. So that's some solid exhibit this behavior, where we call this as uniform cross section. So you can do it at any point and it'll be still the same. And here as well you will see the same behavior. So you will say that, okay, this is A and this is B. Here also you will find that the cross-sectional area is uniform. Now let's look at a cone. So if you view in cone, you will find that at B there would be a smaller circle, and at A you will find the circle is a little bigger. So this will be A and this will be B. So this is not this doesn't have uniform cross section. So uniform cross section solids are interesting because you can find the volume very easily. So the volume of uniform cross section solid would be equal to the cross sectional area is a cross sectional area which is the area of this or area of this side into the length. So if this is your length, so into the length, right? And here as well, if this is your cross-sectional area, into the length, right? So of a cylinder it would be, if this is 2 pi r and L, so the volume would be 2 pi r L or h if this is h. Okay, now the lateral surface area, which is a lateral, that will be equal to the perimeter, which is this plus this plus this plus this. So let's this be L and this be B. So it will be 2 into L plus B would be the perimeter, or sorry, B. Yeah, this is H. Let's say this is H. So B into 2 into B plus H. 2 into B plus H. That'd be the perimeter into the total length, right? So that'll be 2 LB plus 2 LH in this case. So you get the idea that if you want to find the lateral surface area, you can find the area of the perimeter of the cross section, which is perimeter of cross section into length. All right. So now how is this useful? Okay, so this is very useful. This has a lot of applications. For example, let's say you have a pipe, and I say, hey, in this pipe there is some kind of fluid flowing, right? The fluid is flowing in this pipe, and this fluid is flowing at let's say 5 meters per second. That's a great speed. I mean, fluids flowing at 5 meters per second is a great speed. So let's say it's a little lesser speed, which is 5 centimeter per second, right? If you know the cross section, if you know this cross-sectional area, so if you know this area, then we can find the volume flow rate. So the volume flow rate would be equal to A into the velocity. So here it's 5 centimeters square. So if A is, let's say here 10 centimeters square, so the volume would be 10 centimeters square into 5 centimeters per second. That's 50 centimeter cube per second, right? So it's quite convenient for us to think of the cross-sectional area and multiply by velocity, right? So this is one of the applications where you will find in physics and fluids, etc. You will see this being used with the assumption that the pipe has uniform cross-section. So in the next video, we will do some problems of this kind. I hope you like this video. See you in the next one. Bye.